Welcome, welcome. So, first, obviously, we have a bit different of a curriculum here. I'm going to be changing things up quite a bit in the foreseeable future because I find myself at a point of not necessarily where we're getting into a lot of doing, a lot of actions of needing to spend a lot of time simply doing rather than learning. And it's kind of drawing away from my concept of streaming, right? Like, I'm streaming in order to provide learning opportunities and patterns for people looking to get into certain things, right? And if I start kind of extrapolating just normal task work that isn't necessarily learning, I feel like I'm might be doing people a disservice. But what I've came to the conclusion of is the doing aspect is just as much of a I guess you could say, reiteration of the things that has been learned. So, if a year from now I've reiterated a certain topic 50 times and I can now, interact with that topic at X level because of that, I think it's important to have also mm, shown that as well. So, what I'm doing now is we aren't necessarily going to be able to chop everything up into days, right? What are we learning each day is going to be a lot harder to track because our task and projects and the things we're looking to accomplish are going to sprawl. So, what I've started with is I have 6 points within the next 2 months that I'm looking to accomplish. So that we can say by February, we're able to play videos and track if a certain action, their release off the line of scrimmage, was considered good or not. Um, so first, we're obviously going to need a way to have some type of visual output of our code. I want it to show the image that it's looking at. I want it to show the fact that it's found this person, this image. And then from there, we are going to take videos and be able to do the same thing, right? So the start point of a video of where we may be doing a one-on-one versus a receiver and a cornerback, it should be able to start at 0-0 of that video, of this video clip, determine who's the receiver, who's the cornerback, and then from there be able to track throughout the entirety of the video from 0 to the finish, and then from there be able to say, okay, I can put a video in to our training system, our model, in the same way that we have our training data loaders, validation data loaders, have these be filled with the videos to where inside of that video it's being trained on, okay, this is a live video, here's, your route, who's the receiver, who's the cornerback. And then from there we add, okay, you have your object X of wide receiver, object Y of cornerback, and then X if pixels of X is greater than X amount of space from, or Z amount of space from Y, it's considered a good release within the first 3 seconds. You know what I'm saying? So have your programmatic actions onto those track objects, and then we can determine our first data point. So this is going to be kind of the 2 month plan. I know it's already halfway through January, but this is the 2 month plan that we're kind of looking at and wanting to develop. And yeah, I think this will be a lot smoother, a lot cleaner. And inside of here as well, keep the notes of each action, and we will go forward from there. So today is going to be all about visual output, right? I want to run my program, open up some type of window, and have it show what it is that we're working with. So that's what we're going to focus on today, see how far we can get. put in about an hour plus, hour 30, somewhere around there, and then we'll move on from there. So let's get to it. Actually, give me 1 second. All right. So, as with everything else, let's go ahead and kind of start with the basics, right? Well, visual output. So, we are looking for some type of visual output when we run our program. So, how do you employ that, right? How to open image, right? How do I open the image in the first place? Apply action to image, and then move to next image. Repeat as we go through the training, right? So let's start off by coming here, and obviously first we need to, as always, source our virtual environment. And let's start from the beginning. So how to create, or show how does one show image that is being trained on live? Well, I feel like one glaring issue is going to be the fact that it's already cropped. But even render a batch inside of the training loop. So you have a map plot going interactive mode, and then you're actually showing the live batch. So inside of here, okay. So inside of here is where we're going to be able to output that image as it's learning. So show every 10 steps. If step, okay, let's see here. As always, we start with the top and we are importing matplotlib. You know what? Now that we really are sitting and having this all planned out and we're really looking into the future for how we're going about learning things, um, I feel a lot more comfortable really taking our time with each kind of row, each idea, and each concept, even a bit more than we have been doing. So, because seeing here, like, yes, by February, if we can truly understand all of this, and to me, it sounds like we have a lot of time to do this, if we can really lock in and come to an understanding for all of this, I mean, this in just 2 months is huge. And from there, March, April, to have two more of these levels of, concepts to go over, to me, is more than enough time. So as we start here with we're importing matplotlib.pyplot, right? Let's touch on how imports work in the first place, right? So you import an object. What is it? Python. Right. To me, this is importing a library. That's what I would call it. But Python code in one module gains access to the code in another module. So these are modules. So the import statement is the most common way of invoking the import machinery, but it's not the only way. You can do a function, which we're not going to do, obviously. It searches for the name module, then it binds the result of that search to a name in the local scope. So as f. Oh, I see. So you can change what it binds to inside of the local scope by using the as. Search operation of the import statement is defined as a call to the import function. Return value of import is used to perform the name binding operation of the import statement. Direct call to import performs only the search module. When an import statement is executed, the standard, okay, this is repeating itself. Occur. Python has one type of module object, so what these are, right? And all modules are of this type. So regardless of whether the module is implemented in whatever, they're all considered packages. Directories on a file system. So, you have your source and you have your, sorry, you have your packages, which are your source, training data, val data, virtual environment, and modules are the actual files within here. So inside of your source package, right? Yeah, inside of your source package, you're going to have a module of CBU, receiver weight, training.py. Or I guess this works perfectly, right? If I had a source package, then my module would be training.py. Um, we'll use this convenient analogies of directories and files, like file system directories, right? So like file system directories, the source. Packages are organized hierarchically, and packages may themselves contain sub-packages, yeah, because our AI training quote unquote package is containing that source package. It is important to keep in mind that all packages are modules, but not all modules are packages. All packages are modules. The modules we're saying live is the file that lives inside. Okay, so every package lives inside a package essentially, but not every module, the thing that lives inside a package, is another package. Packages are just a special kind of module. Specifically, any module that contains a path attribute is considered a package. I want to say we set this up to work with that somehow. Okay. So you have regular packages and namespace packages. A regular package is typically implemented as a directory containing this is what I'm talking about. It was I had another application I was working on where we I set up the other modules and it was a web page and I was working with Django, Flask, I think, and the creation of the other modules to be used within that different modules for each type of page and a lot of repeated content. So, you know, splitting it up as submodules within the main module made more sense. It was using the init.py that allowed it to be acted or imported upon. When a regular package is imported, this init.py file is implicitly executed, and the object it defines are bound to the names in the package's namespace. And the objects it defines, which are what's inside of it, right? So parent is defining one, um, two, and three, and then one, two, three define itself essentially within that. So importing parent one will implicitly includes execute parent init.py and parent one init.py. Parent dot one. Okay, so you have torch dot neural network dot functional, which will then come down to this functional. It'll be like a functional directory with the init.py inside of it. And then we just import that whole module, yes, module as F. So whatever code is inside of this torch, one directory inside, neural network, one directory inside, functional, we bring that over as F, and then we can say like F dot run thing, right? And then if there's a function inside of this torch, one directory in neural network, one directory in functional, we should be able to run that. Okay, it's a good to for something I use very often. That was very helpful. So we are importing a module, no, a package of matplotlib with a module of pyplot, right? So what does the package of matplotlib do? The dot lib? No, matplotlib.pyplot. So it's visualization within Python. So it's a comprehensive library. So I guess we're going to call libraries and packages the same for creating static, animated, and interactive visualizations in Python. Okay. So it's used for the visualization necessary. And then uh, we are naming that as just plot, it seems like. So import matplotlib.pyplot as plot. We already have our standard, our transformations, so we don't need that. Uh, so interactive mode, right? What is plt.it? Was it? Ion. Ion. So inside of this matplot.pyplot, there is a .ion function that we're looking to run for some reason, right? Enable interactive mode. If interactive mode, then figures will not be shown on creation. Okay. With interactive on, figures will be shown. Okay. So it's just saying we are going to show those figures. And then you have a function of show the live batch, which you are passing in the x's and y's, the class names, and the steps. Image equals the 0, doing some math onto it, some permutations. You put the label onto it, title it, and then pause it. And then for if step, for every 10 steps, you do run the show live batch, which is knocking this out, and then does the learning. Okay. So if we're looking within the same concept, we have our functions for the validate model, for the train model. So let's come up here and create a function for the show live batch, and we'll just toss that inside of the train model. So what is what is XB and YB exactly? I understand it's the X and Y of the data loaders. So the Y's are the the labels, while the X's are, or these are the true labels, while the X's are the group within, the group of images, the groups of tensors, right? And then you're sending it. So why are we using XB, YB instead of just XY though? That's my question. I use XB, YB instead of data loader. Common naming convention in machine learning. Ah, suffix stands for batch. Okay. So you get the X batch and the Y batch. Got you. So inside of your live batch function, we're going to need obviously the tensors. So let's just say tensors, labels, classes, step, right, or epoch, I guess you could say. Um, and so we're going to start by saying, okay, the image itself is equal to the X, the first tensor, dot detach is doing what though? I really dislike that. What the heck? Go away. What is detached doing in an array? The action of detach in an array depends entirely specific on the programming environment. For PyTorch, it creates a new tensor that shares the same underlying data, but is removed from the current computational graph used for automatic gradient calculation. I see. Okay. So it allows me to, it's essentially a copy. It allows me to interact with that and send it to the CPU, I guess. Right. So I get to interact with the first image of the batch, detach from the actual array, and then dot CPU, I assume, is because we're using, not as it makes sense, because sometimes we'll be using the NVIDIA drivers instead of, or CUDA instead of the CPU. So what is dot CPU? From the GPU to the CPU. Okay. So first things first, we take our, I'm still using the wrong. So we have our tensors. So out of our tensors, we start with the first one and we detach it from the rest. So we create that copy and then we send it to the CPU if it's not already there. After that, we have our image equals, we take that image and we apply the STD standardization. How do right? I would need to, that's fine. Let's redefine it. All right. Or actually, watch this. No. I'm not sure what the parameters inside the normalized takes. It might, well, can we do this? And then this. And then just say mean equals mean, possibly. Quite possibly this might work. Mean. Mean equals mean, because this is the array, right? This is either way, this is the array, and then std. Uh, uh, normal mean, and then normal std, which I hope there is no normal std. Normal mean. Normal standard. Go. So then down here, I shouldn't need to, correct me if I'm wrong, but I should not need to, I should be able to say, maybe? Is that a thing? Can I, am I allowed to do that? Let's take a look. Code test func, um, and then we just want to say, yeah, that doesn't make sense because I can't do this. I already know I can't do this. X equals world. You can't, it has to be local to the function itself, right? Why isn't that? Ah, I see. Def test func. Correct me if I'm wrong though, right? We're gonna see. Oh, I guess you can. Okay. So if you have it globally, then you can just interact with that. But what if I define this and then I say uh test, right? So then the local x takes over. But if there is no local x, then I can just say this normal mean, and then use normal mean here, and those should both work. No. My bad. My bad, my bad, my bad. Yeah. Okay. Cool. So I should be able to come here and just say normal std plus your normal mean as we have showing here. And oh, we're unnormalizing it. Huh? I guess we don't. I guess we need to see it how we had it and put it in the first place. Permute 1, 2, 1, 2, 0 numpy. So what is this doing, right? Uh, what is? Because to me, you're creating this image object, and somehow, I guess I need to see the difference between an unnormalized and a normalized picture, right? Difference between normalized and image. Picture. I mean, this is basically what we're looking at, right? All right, all right, all right. This is basically what we're looking at in the sense of, we could just think of this as the y-axis of the image. We're saying, okay, that's cool and all, but let's shove the entirety of this y-axis down to fit this normalization of what we're working with. So after, okay, I see. So we smush it and change it, uh, the parameters and the dimensions of the image in order to fit the ResNet backbone. So this is saying apply that same normalization in reverse, and then dot clamp is going to do something. Let's see, what is dot clamp? The one going clipping. So clamping is the clamping or clipping is the process of limiting a value to a range between a minimum and maximum value. So we are clamping it to 0, 1 after we apply the normalization to it. Um, but I feel like that's. literally what's happening here, though, is my understanding. This is the point of normalization, and then we're applying another normalization onto it. I feel like that's going backwards, right? So let's try to understand that, right? Actually, no, let's keep going. So the label is equal to the okay. So you take the integer of the first um you take the integer of the first label inside of the array for the batch, and then you detach it. So we're copying again, and we send that over to the CPU from the GPU. So we can say our label is equal to labels, our first one, dot detach from the array itself, and then send it over to the CPU. And then we have to make that an integer for some reason. I'm not sure why. Why are we? I don't see a necessary reason to make it an integer. We're not actually doing any actions onto it, so we can leave that as is. So our plot function, or sorry, our plot module now has a CLF action done onto it. So PLT or plot lib, and then that was CLF. The clear figure is used to clear the entire figure, including all axes and subplots. So we start off by clearing the figure. It was plot.clf. And then after we clear the figure, I assume our next step would be plotting the image, right? So plot.imshow, which I again assume is going to be image show. Imshow that image, and then we're not necessarily looking to do the whole. Why not? Right? Why not? Let's go ahead and do the title and everything. Yada yada. Classes step um, plot axis off, which is doing what? Yo, if this does this one more time. Oh my lord. All right, plot axis is a function. Oh, this is. Oh no, this is showing how to do it. Can modify the plot's appearance. I'm curious, but like, let's see, let's see what happens, and from there we can determine if it's what we need or not. Because I understand this sounds a lot like just graphing points, so I'm curious if this is actually graphing the models or more so the right or wrongs within the data. So inside your training loop, all right? So validate model, no, train model, right? So inside of here, for x and y, so above here, so we go step equals 0, and then after you finish the optimizer step, that's considered a step plus equals 1. So let's just do 100, and then as you do this, if step is divisible by 10, we're going to run the show live batch function, which is going to input the tensors, uh, which is x. It's going to take the y batch. It'll take the training dot classes, which is present where I know I can pull that from somewhere. I just don't know where. Is this training data? I mean, this is global, so I could just say training data dot classes, and then the last one is steps. So let's see what happens. Let's see what happens. Training dot no module name matplotlib. I assume I'm gonna have to say uh pip3 install matplotlib. Le voilà. That makes it. Did I not do it in my? I'm inside of my virtual environment. Let me double check. Python packages. It's a virtual environment. Pip. You create the environment for activate the environment, which I did. Install. Yeah. Okay. Weird. Because if I say deactivate, okay. Let's first check this. Right? I run it now. Okay. Nothing as far as that goes. So it was saying what plot, then replace the body. Show live batch body. Come on. I also don't have a requirements folder. I could probably pull one though. Don't find the GUI. Don't preview images to disk while training. Save live. Nah, I want a GUI. I want a GUI. Okay. We might just switch over to VirtualBox, honestly, if this is the case. So that I can actually. Yeah, I think that's gonna be the plan. Okay. So, this is what we need, of course. So, first, utilize matplotlib for visualization. Visualization over to VirtualBox, and we're gonna end up installing Ubuntu 2404, recreate virtual environment, install VS Code. Well, I guess you're gonna need to install VS Code, recreate virtual environment, and get output showing. So we understand this. Next up, we're gonna have to move over to VirtualBox, install VS Code, recreate the environment, and get the output showing. From there, um, create order box around object, instantiate object. So hopefully we'll be able to say like, okay, X equals object or image with border box around, and then be able to say uh, flip X upside down or whatever the case may be. Somehow, some way interact with that object, and then we can start the videos. So I'm missing a step here actually. We are going to need to do this. Well, okay. Here's where we'll end up starting to have to train on two different objects at a time. Essentially, we'll need to be able to see the cornerback and the receiver at the same time in one image. So part of me feels like we have the training down. We understand how to train, how to make the AI from scratch, but we made a wrong turn somewhere. We can find the object. We can differentiate between two different classes within one object, with that one class being inside of that image. But we don't know how to handle two of the same images inside of, or two of the same classes inside of one image, and being able to differentiate between the two. So realistically, this should be first. Train two classes within one image. But I feel like that's the reason you need the border box, to be able to say, okay, this is the receiver, this is the cornerback. So really, this should live here. So after we move over and we install, recreate, let's have a first step here of train on two classes in one image. And then we get the output of that showing, create the border box around each class found, and then instantiate objects of classes afterwards. That sounds good to me. So tomorrow we'll be knocking out definitely this, and we will go ahead and get the images. Collect, get the images for this training. Collect images, and this will be a lot easier because I can get videos. There's a lot of videos of obviously, professional one-on-ones or clips of winning routes. So I'll easily be able to get images of cornerbacks and receivers side by side. And then from there, we could just start training. So, granted, I do think the fact that we went one by one is going to be important as well. You may have to start with being able to differentiate one and the other and then start training on both. I don't know. That's what we are going to find out. Outside of that, I don't really have anything else for today. So, hope y'all learned something, and I'll see y'all tomorrow.